Have you ever stopped to question, how fast does light really travel? It's a simple query, but one that opens up a vast world of scientific intrigue and mystery. When we talk about the speed of light, a number that often comes up is 300 million meters per second. This figure, impressive as it is, has become a staple in physics classrooms and scientific discussions worldwide. Yet what if I told you that this number isn't as straightforward as it seems? Yes, you heard that right. The speed of light as we know it is not as clear-cut as 300 million meters per second. The truth is, this figure is a product of a measurement method that might not fully encapsulate the actual speed of light. This method is known as the two-way speed of light, a concept we will delve into later. However, this raises an interesting conundrum. If the speed of light we know is based on the two-way speed, what then is the one-way speed of light? Could it be possible that the one-way speed of light is different from the two-way speed? And if so, how would this affect our understanding of light and its behavior? These questions are not just philosophical musings. They have tangible implications on our understanding of the universe and its fundamental laws. The answers to these questions could potentially reshape our understanding of physics and the universe as a whole. So, as we embark on this journey of discovery, let's keep an open mind. Let's challenge our preconceived notions and delve deeper into this fascinating topic. After all, science is about questioning the known and exploring the unknown. Is the speed of light we know the actual speed of light, or is there more to this story? As we unravel the mysteries of light speed, we might just find that there's more to this tale than meets the eye. So buckle up and get ready for a thrilling exploration into the enigmatic world of light speed. Imagine a beam of light traveling from point A to point B. Now, let's delve into the concept of one-way speed of light. It's the time taken for light to travel from one point to another without any reflection or bouncing back. Sounds simple, doesn't it? Well, let's think about it this way. When we talk about speed, we're referring to the distance something travels over a certain period of time. In this case, we're talking about light, which is not just any ordinary traveler. Light is the fastest thing in the universe, or so we're led to believe. Light doesn't meander along a path, it zips through space at an unimaginable pace. It travels at approximately 300,000 kilometers per second. To put that into perspective, light could travel around the Earth 7.5 times in just 1 second. So when we talk about the one-way speed of light, we're talking about the time it takes for light to zip from point A to point B without any pit stops or detours. Now you might be thinking, that doesn't sound too complicated. Why can't we measure that? Well, the issue lies not in the concept, but in the practicality of measuring this speed. You see, to measure the one-way speed of light, we would need to know the exact moment the light leaves point A and the exact moment it reaches point B. But remember, we're talking about something that travels faster than anything else we know of. How can we possibly measure that with the precision needed? How do we ensure that the start and end points of our measurement are accurate? These questions highlight the challenges scientists face when trying to measure the one-way speed of light. Moreover, the methods we currently use to measure the speed of light are based on its round trip, not just one way. This is what we call the two-way speed of light. This means that the speed we often refer to, that 300,000 kilometers per second, is actually the average speed of light going to a point and coming back. It's not the true one-way speed. So the one-way speed of light could be faster or slower than this average. We simply don't know, and that's the crux of the matter. Our current understanding of the universe is based on the assumption that the speed of light is constant in all directions. But if the one-way speed of light is different, it could completely change our understanding of the universe. Sounds simple enough, right? But measuring this one-way speed of light is not as easy as it sounds. Why is it that we can't measure the one-way speed of light? That's the question on our minds as we delve deeper into this cosmic conundrum. Let's start with the challenges. The primary obstacle in measuring the one-way speed of light is the synchronization of clocks. Imagine for a moment, you have two perfectly synchronized clocks at two different points, A and B. You shine a light from A to B, timing how long it takes to travel. Sounds simple, right? But here's the catch. To start and stop the clock at the exact time the light leaves A and arrives at B, you'd need to be in both places at once. And unless you've discovered teleportation, that's not going to happen. Okay, so what if we use a mirror at point B to reflect the light back to A? Well, now you've just measured the round trip, or two-way speed of light. We're back to square one. Don't let this discourage you. This is where the fun begins. The synchronization problem leads us to another fascinating concept, the idea of simultaneity and relativity. In Einstein's theory of relativity, the notion of simultaneity is relative to the observer. This means that what appears simultaneous to one observer may not appear so to another. Let's visualize this. Suppose you're on a moving train and you see two bolts of lightning strike the ground at the same time. Now, imagine someone standing still, watching the train pass. From their perspective, the lightning strikes may not appear simultaneous at all. One might seem to strike before the other. Now, apply this concept to our light speed experiment. If you start your clock at A when the light leaves, and stop it at B when the light arrives, the times will be different depending on your frame of reference. Are you at point A, point B, or somewhere in between? This relativity of simultaneity complicates the measurement of the one-way speed of light. So, despite our best efforts and most sophisticated technology, the one-way speed of light remains elusive. We can measure the round-trip speed with precision, but when it comes to the one-way journey, we're left in the dark. This isn't a failure of science, but rather a testament to the complexities of our universe. It's a reminder that there's always more to learn, more to explore. So the one-way speed of light remains a mystery, but who knows? Perhaps one day some bright spark will find a way to unravel this cosmic conundrum. Until then, we'll keep peering into the vast expanse of space, in awe of the mysteries it holds. Now, what about the two-way speed of light that we're all familiar with? Let's delve into this concept, shall we? The two-way speed of light is basically the average speed of a light beam going out and coming back. In other words, it's the round-trip speed of light. Now here's how it works. Imagine you're standing in a room holding a flashlight. You point the flashlight towards a mirror on the opposite wall and switch it on. The light travels from the flashlight to the mirror, bounces off, and returns back to you. The time it takes for the light to make this round-trip journey is measured, and based on that, the speed of light is calculated. This process, in essence, is how the two-way speed of light is measured. It's a simple and reliable method that has been around for a long time. And the speed that we get from this method is the one we all know and love, approximately 300,000 kilometers per second. Now, you might be wondering, if the two-way speed of light is so straightforward to measure, why do we even bother with the one-way speed of light? Well, the thing is, the two-way speed of light doesn't necessarily tell us the whole story. You see, when we measure the two-way speed of light, we're actually taking an average of the speed of light going out to the mirror and the speed of light coming back. But what if the speed of light isn't the same in both directions? What if for some reason light travels faster in one direction than the other? In that case, the two-way speed of light would be just an average of two different speeds. It wouldn't tell us the true speed of light in either direction. And this is where the one-way speed of light comes into play. It's an attempt to measure the speed of light in just one direction without any bouncing off mirrors or returning back to the source. But there's a catch. Measuring the one-way speed of light is extremely difficult, if not impossible, with our current technology and understanding of physics. That's why the two-way speed of light is still the commonly accepted speed of light. It's the best we can do for now. So the next time someone tells you the speed of light is 300,000 kilometers per second, you can tell them, well, actually, that's the two-way speed of light. The true speed of light might be something different. But remember, this two-way speed of light might not represent the true speed of light. So where does this leave us? We've ventured deep into the realms of light speed, uncovering the twist in the tale that the speed we're so accustomed to, the 300 million meters per second, is actually the two-way speed of light. We've seen how this speed is calculated by bouncing light back and forth between 2 points and averaging the time it takes for the journey. We've also explored the elusive one-way speed of light, the speed at which light travels from point A to point B without bouncing back. It's a concept that has perplexed the brightest minds. Albert Einstein himself grappled with it in his theory of relativity, leading him to the conclusion that the one-way speed of light is not just difficult, but impossible to measure with our existing technology and understanding of physics. Why is this so? Why can't we measure this fundamental property of one of the most ubiquitous phenomena in the universe? It all boils down to the limits of our current technology and the constraints of our understanding of space and time. We're still bound by the constraints of simultaneity, the concept that two events occurring at different locations can be observed to occur at the same time in one reference frame, but not necessarily in another. This mind-boggling aspect of Einstein's theory of relativity poses a significant challenge in measuring the one-way speed of light. So we find ourselves at a fascinating crossroads where we understand the universe in unprecedented detail, yet are unable to pin down the one-way speed of light. It's a humbling reminder of the mysteries that still lie hidden within the fabric of our reality. As we continue our quest to unravel these mysteries, we push the boundaries of our knowledge, inching closer to a deeper understanding of the universe and our place within it. The speed of light, a fundamental constant of nature, remains one of its most intriguing mysteries. But why does this matter, you may ask? Well, the implications of these findings are far-reaching. It's not just about the speed of a photon traveling through the cosmos. It's about the very fabric of our understanding of the universe and the laws that govern it. Let's take a moment to ponder. If the one-way speed of light is truly variable or different from what we've always assumed, it could potentially rewrite the rulebook of physics. The constancy of light speed forms the bedrock of Einstein's special theory of relativity, a cornerstone of modern physics. If this constancy is called into question, it could have significant implications on our understanding of time, space, and matter. Moreover, it could also impact our understanding of cosmology, the study of the universe at large. The assumption of a constant speed of light is fundamental to our calculations of the size and age of the universe and the distances between galaxies. If the speed of light is not a constant, we may need to reassess our understanding of the universe's scale and its history. But before we get carried away, it's important to note that this is still an area of ongoing research. Scientists all over the world are studying the one-way speed of light, seeking ways to measure it accurately, and grappling with the theoretical and practical implications of their discoveries. It's a fascinating journey of exploration and discovery, one that could potentially revolutionize our understanding of reality. So the next time someone tells you the speed of light is 300 million meters per second, remember, it's not the whole story. There's a bigger picture, a grand tapestry of cosmic proportions that we're only just beginning to unravel. And who knows? The mysteries we uncover might just lead us to a new, deeper understanding of the universe and our place within it.